Let's talk about the tangential and radial acceleration. Uh, in general, before beginning with this, if we have a linear motion of any object, we have here an object with a linear motion with a velocity v. Uh, if v increases, so a the acceleration and v have same direction, like this. This is v, and we can draw here a. Here we have a. In the linear motion, we talk about a x and a y. Okay, we can put here ax and ay, ax and ay. And we said that a equal ax plus ay, and the magnitude of a equal radical ax square plus ay square. So we use this equation in the case of a linear motion. Also, we can use it in other kind of motion, but especially in the linear motion when you use ax and when you use the xy components, when you use the Cartesian coordinates. But if we have a circular motion trajectory like this one, we have a trajectory takes many direction. In this case, you have to use a equal a tangent plus a radial. Okay, a tangent must be measured in terms of a unit vector e tangent, and a r must be measured in terms of the unit vector er. Okay, these are a unit vector. Okay, let's represent AT, AR, ET, ER on the graph. AR must be directed toward the center of the circle. Why we use this circle? Any trajectory like this, at any point you can have a circle like this one. For example, this circle must be intersect with only one point with the trajectory, like this. Just one point here. If you increase the size of this circle will touch the trajectory with many points. So we cannot do it. So we have to use only a circle in the way that this circle will intersect with the trajectory with only one point. At the point, for example, at this point, you can use another circle bigger, like this. Look. So here the circle intersect only by one point with a radius r2. This one has a radius r1. So every point on the trajectory must have a new circle. If I take our example here, we have the point A, the point B, and the point C. The point A has a circle with a radius RA. The point B, a circle with a radius RB. And the point C with a circle. As you see here, we have a big circle here. You can put a big circle here because you can take it bigger to this point. If you increase more, the circle will intersect with many points. Okay, you cannot do it. You have to keep touching with only one point. Okay. Now we talk about the A tangent. A tangent of a radial. A radial must be directed toward the center. As you see here, this is a radial. Here you have a radial, and here you have a radial. Always toward the center of the circle. Okay? Here you have the center 1, here the center 2, and here the center 3. So remember that AR is directed towards the center. As a numerical calculation, AR equal minus V square divided by the radius. This why you have minus, because the unit vector is directed outside. Here you have the unit vector like this, and the unit vector E tangent is in the direction of V. You know V is tangent to the trajectory. So here we have the velocity. A tangent has the same direction as V. If V increases, AT and V have the same direction. If V decreases, so AT and V must have an opposite direction. Okay, and about AR has the opposite direction of ER, and we can see here we have ER, and this one is ET. AT in the direction of ET, and ER and AR are opposite. So you can write AR like this, or you can put a vector in the position of minus ER, okay? Because AR and the unit vector ER are opposite. It's like if you have X and Y, and you have a vector like this, V, this vector equal minus Vj. It's the same, it's the opposite direction if you take Y and you take X. So in the Cartesian coordinates, V in this direction equal minus the magnitude V times the direction J. Okay. Now we don't talk about J and I, we talk about ER and AT. So remember that as magnitude, AR equal v square over r. This is the magnitude of AR. Second, we talk about AT. About AT. If the v as velocity increases, so AT and v have same direction. If v decreases, so AT and v have opposite direction. Okay, here we take the case where v increases. So AT and v have the same direction. AT and v have the same direction in all these points. By calculation, AT equal dv, the derivative of the velocity, of the speed, because absolute value, equal d over dt, v equal vx square plus vy square. So you have, for example, v and vx and vy in function of t. You have to calculate the derivative of this value. We can calculate AT. Here we have two principal equations of AR and AT. In general, the magnitude of A equal A tangent square plus A R square. So you can calculate easily. Oops. A tangent equal, you can write its value here. Okay, we have some problem. Okay, you have to calculate the values in this equation, or you can write here A square equal A R square plus AT square. AT square. Okay, this is in the case of a trajectory as a circle. Let's take a special case. A special case. If we have a projectile, in the case of projectile, here we have x and we have y, and I take an object. The object will take this trajectory. Okay. This trajectory. At this point, we have v is tangent to the trajectory. You can draw a circle like this at this point.